Hi, this is Miss Boyd, and this is your lesson for today on centers of triangles. You have your graphic organizer. We're going to be looking at the circumcenter and the incenter today. So the circumcenter, that would be point M here. Here's our circumcenter. That is created by perpendicular bisectors. So we're going to fill that in. Perpendicular bisectors. And some things we need to know about the perpendicular bisectors and the circumcenter is the circumcenter is equidistant from each vertex of the triangle. Now, what does that mean? It's equidistance from the vertex of each triangle. That means when I go from point M to point A, that's the same length as going from point M to point C, and that's the same length as going from M to B. So all of these lengths that go from the circumcenter to the vertex are the same. What that allows us to do is if we were to take our compass tool and put the center on M and our other point on C, we can draw a circle around these points. And my circle is very terrible. Okay, we can draw a circle around those points. Okay, going back to the incenter. The incenter is created by angle bisectors. Angle bisector. Okay, so that is created by the angle bisectors. Okay, now what that means is we've got point M again here. That is where all the angle bisectors meet. So what does that mean? That means when I split B into the two equal angles, it goes right through M. When I split C into two congruent angles, it goes right through M. And when I split A into two equal angles, it goes right through M. So all of those points of intersection from the angle bisectors create M. So what do we need to know about the important facts? Well, the incenter is equidistant from each side of the triangle. So if I come back and I look at the sides, you can see that from M to the side, it's always at a 90-degree angle, and it's going to be the same distance away from MX. That's also going to be at a 90-degree angle, and MZ. So all of these segments from the incenter to the side are going to be 90 degrees to it, and they're going to be congruent. What that allows us to do is to take our compass and put our point here and our other endpoint at Y, and we can draw a circle inside the triangle on all 3 points. That's why it's called the incenter. Circum means to go outside, around. So this goes around the triangle. So that's one way you can tell the difference between the two. Okay, in just a moment, we're going to move on. Okay, so there's some other things that we need to learn about our perpendicular bisector, and that's the perpendicular bisector theorem. If a point lies on the perpendicular bisector of a segment, so say the green point, point F, then it is equidistant from the endpoints of the segment. Okay, so that means FB is the same distance as FA. They are equidistant. So if I go to point H, HB is going to be the same as HA, and so on with E and G. So let's take a look at examples that might use these properties. So example 1 says BC is the perpendicular bisector of AD. So we already know this is the perpendicular bisector, and we want to find the value of X. Well, here's x. Well, what do we know? If it's a perpendicular bisector, that means it splits this segment into two equal pieces. So how do we set this up? Well, we set it up algebraically. 7x plus 10 is going to equal 9x minus 2. So then we solve for x. I take my smaller one, x, over to my larger x. So I'm going to subtract those. I get 10 is equal to 2x minus 2. Then I'm going to take negative 2. I'm going to add 2 to both sides. I get 12 is equal to 2x. Divide by 2. And x is equal to 6. So we have found x. X is equal to 6 based on what we know about perpendicular bisectors. Okay, example 2. N is the circumcenter. Here's my circumcenter right here of triangle RAK. Find values x and y. Well, being that that's the circumcenter, that means that's where all the perpendicular bisectors meet. So I have 3 different perpendicular bisectors, one for each side, and I want to find the values of x and y. Okay, so if I find x first, that is the result of the perpendicular bisector YE. And just like the last problem, we know that those are congruent. So 3 times x plus 3 equals 21. Now, normally I would do the distributive property. So I get 3x plus 9 equals 21. I'm going to subtract 9 from both sides. 3x is going to equal 12. Divide by 3. And x is going to equal 4. So we found x. X is equal to 4. Now I want to go back and find y. Okay, so y, I have this blue dotted line that is 4y minus 3, and I have this other blue dotted line that is 9. Okay, well, since this is the perpendicular bisector, that means anything along that point is equidistant to the endpoints. Equidistant means they're the same distance. So that means that 9 equals the 4y minus 3. They are the same distance apart because of the circumcenter N. So I'm going to solve for y. I'm going to add 3 to both sides. I get 12 equals 4y. Divide by 4. And 3 is equal to y. So now I have y. I'm going to move it down for the next section. So when we're working with the angle bisectors or the incenter, we need to know important information about that one as well. If a point lies on the bisector of an angle, then it is equidistant from the sides of the angle. That means my pink lines are equal, my green lines are equal, my blue lines are equal, and my orange lines are equal. Okay, what they also don't show here is that these are all right angles. It has to be perpendicular to the side. Okay, so all of these are also 90 degrees like we depicted in the previous one. Okay, so anywhere along the angle bisector, it's going to be equidistant to the side, and it's going to be perpendicular at that side as well. Okay, so for example 1, find the value of x. Okay, well this is an angle bisector, so that means it splits the angle in half. So that's 7x plus 17 is going to be equal to 3 times 4x minus 1. Okay, I'm going to distribute. This is all becoming algebraic. So I'm going to rewrite 7x plus 17. Distribute. I'm going to have 12x minus 3. I'm going to take the smaller x over to the larger x. So I'm going to subtract 7x. I get 17 equals 5x minus 3. I'm going to add 3 to both sides. 20 is equal to 5x. Divide by 5. And x is equal to 4. Okay, so the missing x is going to be 4. Okay, example 2, QS is the angle bisector of triangle PQR. So QS is the angle bisector. Find the value of x. Okay, well, I have a red angle, that's the entire angle. That's 13x minus 1. And I have the purple angle. Well, the purple angle is half of the big angle. So I have to take half of this, and that's going to equal the 6x plus 4. Okay, I don't want to distribute that just because it's going to give me decimals, and I know we love decimals. So I'm going to do the opposite of multiplying by half. I'm going to multiply by 2 on both sides. Okay, well, what does that do? That allows me to cancel out the half. But now that distributive property has shifted over to the 6x plus 4, because now I'm going to multiply everybody by 2, which is better than having decimals. So I am left with 13x minus 1. And now I'm going to distribute the 2. I have 12x plus 8. I'm going to solve for x. So I'm going to take my smaller x, and I'm going to subtract it from both sides, and I get x minus 1 is equal to 8. And then I'm going to add 1 to both sides, and x is equal to 9. So there's my answer. X is equal to 9 for the value of x. Okay, also keep in mind that the distances, anything that's on that angle bisector is equidistant from the sides. So it looks a lot like this one here in example 1. You might be given this is 8. Well, guess what? That means this piece is also to equal 8. Okay, so those are the things that you need to know for today's assignments.